Okay, so this video, we're going to cover section 8, which deals with integral exponents. Integral meaning that the exponents are integers, but later in the course, we'll see that the same properties that we're going to cover here apply if the exponent is a real number or a fraction. But for now, we'll focus on integral exponents. So the idea is, these properties that we're going to cover dealing with exponents is that we are going to perform, operations of multiplication, division, exponentiation, and we'll see exactly what happens to the exponent of a number or a variable when these variables or numbers get multiplied, divided, or exponentiated. So before we begin, so take a look here at x to the fourth. So the variable x we call the base, and the number 4, which is a little raised and to the right of the variable, is called the exponent. So the basic definition is, if you have a number or a variable raised to an exponent, in this case 4, the definition is you will multiply that variable or that number that many times. So x to the fourth is x times x times x times x 4 times. Not 4 times x times itself 4 times. All right, so that's the first property, which is basically the definition. And now let's take a look at the 3 basic properties, the first 3 that we have. We have the product rule, which is right here. We'll take a look at the quotient rule, which is division, product rule, multiplication, quotient rule, division. And then your textbook talks about the zero power rule, which is just, in essence, any number or variable raised to the power of 0 or to the number of 0. We'll take a look at that in a minute. So I'll go over the definition, and then we'll do some examples. So here's the product rule, first rule. And the product rule says that if you have variable or number raised to an exponent, if the bases are the same, right? In this case, the x's are the same, all that you have to do is add the exponents. So x to the 4 times x squared would be x to the 6th power, as you can see here. So that's the product rule. Now, this only works if the bases are the same. In this case, I have x to the 4th and x squared, which is fine. But if I had x to the 4th and y squared, that would not apply. So same base. If the factors are being multiplied, we add the exponents. Now, for the quotient rule, meaning division, it's similar. Provided that the bases are the same, like we have here, x to the 6 divided by x squared, all that we do is we subtract the exponents. And it's going to be the numerator exponent, 6, minus the denominator exponent, 2. So in this case, x to the 6th divided by x squared would be x to the 6 minus 2, or as you can see here, x to the 4th. So quotient rule. Again, only applies if the bases are the same, right? X to the 6, x squared, okay. We'll do some examples in a few minutes. And the last rule, this is probably the simplest rule, is the zero. They call it here zero power rule, but it's just the zero exponent rule, right? So if I have, as you can see here, under the solution, x to the 3rd, x to the 3rd, by the quotient rule, we would have 3 minus 3, which is 0. So x to the 0. So any number, this is the rule, any number or variable raised to the 0 power is 1. No matter how complicated it is, I guess we'll see an example later. If we don't, I'll give one to you so that you can see that anything raised to the 0 power is 1. Okay, x to the 0, y to the 0, 5 to the 0, 6 to the 0, and so on and so forth. So these are the 3 basic rules. Okay, now let's take a look at some examples that I copied over here. So integral exponents. Here are the three rules that we talked about: product rule, quotient rule, and the zero power rule, or just the zero exponent rule. Okay, so let's take a look and we'll do some examples that we have over here. Okay, so in the first case, I have, seems like it's complicated, right? I have, first expression times the second expression. What you're going to do is you are going to match the variables, pair up the like variables. Now, this is multiplication. So the -4 is going to multiply the -2. We get 8. Then we have a to the 0 times a squared. And you can do it, aside somewhere. Okay, a to the 0 times a to the second power. This is the first rule, which is the product rule. So I'm going to add the 0 and the 2, and I will get a squared. You do the same thing with the b4 and the b. It's just b, but when there's no exponent, okay, when there is no exponent, the default is 1. So this is b to the 4 times b to the 1. Same base, we add the exponents. So b to the 4 times b to the 1, b to the 5th. And the same thing is done to c squared and c cubed. Same base, keep the base, add the exponents, 2 plus 3, 5. Okay, so this is the final answer for the first problem. So we have multiplication. If there are any numbers, we multiply them before, as we did here with the 8. And then we apply the property individually to each variable. And we pair up the like variables, because the property only works if we have the bases being the same. All right, very good. Let's take a look at the second example. I'm going to do this A10 right here. And this looks like I have the quotient rule, right? So again, I have a number, -20 divided by 4. So we take care of that first, -5, right? Negative divided by a positive negative, 20 divided by 4, 5. And then, look, I am going to take care of the x4 divided by x9. Now be very careful here, because the quotient rule says that I have to do this exponent minus that exponent. So this would be x to the 4 minus 9, which is -5. Okay? So x to the -5. And I only have a single variable left, which is the y square, and there's nothing to do with the y square because the y square is by itself. All right, so not quite the final answer, because I need to do something. I'm going to show you now because I don't want to leave the answer this way. So one note that you have to be aware is, note the final answer, okay, must never have a negative exponent. So this is very, very important. So you have to keep a note of that. And this is my final answer so far, but I have this -5 exponent here. So I'm going to show you in the next block, but in here, I'm going to give you the answer now, that this cannot stay this way. Okay, so what do we do? So first of all, I'm going to write this as -5, x to the -5, y squared, everything divided by 1, right? I can do that. Just like the number 5 is the same thing as 5 divided by 1. Now, when you do have a negative exponent in the numerator, I just gave you a rule that the final answer cannot be negative. So this whole variable with the exponent goes to the other side of the fraction, and when he flips, the exponent changes to positive, okay? So the final answer to this question would be the -5 stays the same, the y squared stays the same, and the x to the -5 goes to the denominator as x to the 5th. Now, this is our final answer right here. Okay, so -5y squared divided by x to the 5th. Okay, so on the exam and on the final, this is the answer we are expecting. Okay. And we'll take a look. I'll go over this property in a few minutes. It's just that it shows up here in this problem, and we want to give you the complete correct answer. Now, the next problem here, 8.12, we have two problems in one. In the numerator, I have the product rule, as you can see, and then I have the denominator. So you can do, this problem different ways. I will do the following. I'll take care of the numerator first by applying the product rule, and then I will take a look at the simplified numerator and apply the quotient rule with the denominator. So then I have to do x to the 5th and x squared, right? So multiplication product rule, same base, keep the base, add the exponent. So 5 plus 2, 7. And then I have the two y's, okay? I have y to the 1 here and y to the 1 there. So remember, when there is no exponent visible, the default is 1. So I have y to the 1 times y to the 1 is y squared, 1 plus 1. And here is the denominator, which stays the same for now. Okay, so now this is my simplified problem. I'm not done yet. I have to continue. And I have to pair up the x's, and I have to pair up the y's. Now, y squared divided by y squared, they both cancel each other out because this will be quotient rule. 2 minus 2 is 0, and y to the 0 is 1. So these two cancel. So I am left with this now. Not quite the final answer yet, but I then apply the quotient rule here. So this will be x 7 minus 9, which is -2. And it becomes a problem similar to this one right here, where the negative exponent cannot be in the final answer, and it goes to the other side of the fraction as positive. Okay, so if you have a variable with a negative exponent, it must go to the other side of the fraction, and when it does, it becomes positive. Okay, so the -2 exponent goes to the denominator, and the x -2 becomes x +2 exponent. So here is my final answer, 1 over x squared. Okay, very good. Now let me go back. So these are the, 3 basic examples, the product rule, quotient rule, and the negative exponent rule that we've covered here. We also covered, the 0 exponent rule. So here is the 0 exponent rule. Okay, so we've covered these 3 basic properties, and also the negative exponent rule, as you can see down here. But we'll give you more specifics as we move on. So we've covered the first 3 properties. All right. Here is the negative exponent, as I said, right? In the case of problem A13, I have x cubed divided by x to the 5th. That would be x to the -2. But I cannot have x to the -2 as my final answer. X to the -2 is in the numerator, and it has to go to the denominator as positive. And I'll give you an example if the negative exponent is in the denominator, what we have to do. So here is the x to the negative 2 becoming 1 over x squared. Okay, so wherever the negative exponent here, so here's the negative rule. If the negative exponent, as you can see here on the left, is in the numerator, it goes to the denominator as positive. And on the right, if the negative exponent is in the denominator, it goes to the numerator as positive. Okay? And let me see if we have an example here for you. This is the rule as just gave it to you a couple minutes ago. Yes, we do. We have a couple problems. So let's take a look and do those two problems first. In the first case, the 817, all of the variables are unique. So I cannot apply any of the product rule or quotient rule because those are only applicable if you have a common base. But all of the exponents are negative, which means we have to turn them into positive. Meaning what? If the negative exponent is in the numerator, like a and b right here, they have to go to the other side of the fraction. So this will go down and this will go down. And in the case of c to the minus 3, it's in the denominator, it goes up and then it becomes positive. So the final answer would be the following. C cubed, positive, numerator, a to the 1, or just a, times b to the 7. Okay? So all of the variables that had negative exponents in the numerator go to the denominator, and the variable with the negative exponent in the denominator goes to the numerator. Now, the 818 is a more general problem where we have two variables, we have product rule, and we have quotient rule. So first we take care of the 6 divided by 12. Now we can't, completely divide this, so the best we can do is simplify by 6, right? So 6 goes into 6 once, and 12 goes into 6 twice. So this is as far as I can simplify. Now I have, I can write it here on the right for you to see, m to the minus 3 over m to the third power. This is the quotient rule, right? So be very careful. So this is this exponent minus this exponent. So minus 3 minus 3 minus 6. So in the numerator, I have m to the minus 6. And we'll do the same thing with the n, right? N to the 4th and negative 2. So this is the quotient rule again. So it's this exponent minus this exponent, which happens to be negative. So this will be 4 minus a minus 2, which is 4 plus 2, which is n to the 6th. So this is my temporary final answer, but I have to handle the m to the negative 6. Now, as we said before, this can be negative here, and if it is negative in the numerator, then it goes to the denominator with the positive exponent. So the m to the minus 6 goes to the denominator and becomes m to the positive 6. Now the n to the 6 stays right here. So this is my final answer. And obviously you don't have to put the 1 if you don't want to. You can write the final answer as n6 to m to the 6. So that's our final answer. Okay. Very good. We have two more examples dealing with negative exponents. Let me show you first another property, which is the last property that we have here. which is when you have a power raised to another power. So this is a power of a power. This is what we call, exponentiation of another power. So if you have an exponent of another exponent, as you can see here in problem 819, x squared raised to the third power, all that we do is we multiply the two exponents. So this will be x to the 2 times 3, which is x to the 6. So this is very simple, and it doesn't matter if you have multiple variables in the numerator or if you have variables in the denominator. The same applies. So an exponent of an exponent, all we do is we multiply the two exponents. Okay? So this is the last property, and like I said, it doesn't matter if you have like problem 819 in the numerator only, or in problem 821, where you have here x to the 4th square, and in the denominator y cubed square. Now, the exponentiation takes place in the numerator and in the denominator. So, for example, in this case, problem 821, we would have to square the 5, x to the 4 square, as you can see here, right? 5 square, x to the 4 square, and then y cubed square in the denominator. So 5 squared would be 25. X4 squared would be x to the 8, 4 times 2. And y cubed square would be y to the 6, 3 times 2. So it doesn't matter if you have an exponent in the numerator or denominator or both, the exponentiation takes place in both cases, okay? And that's the last property we're going to see. And I have a few examples here. These are the examples that we're going to cover. These are the last 4 dealing with the last property, which is an exponent of an exponent. And because this is the last 4 problems, we also have the situation where you may have to deal with a negative exponent, okay, which is perfectly fine. So these 4 problems are probably the most complicated cases that you can see, because you may have multiple properties in one question. So the first case, I have x to the negative 2 to the 5th. So you can do this a couple of different ways. You can handle the negative exponent first, or you can do the exponentiation first. It doesn't really matter. So I'm going to do the exponentiation first. So x to the negative 2 raised to the 5th power is x to the negative 10, right? Negative 2 times 5. Y to the negative 4 to the 5th power would be y to the negative 20th power, because negative 4 times 5. Now, this is almost my final answer, with the exception that both exponents are negative. Now, we can't leave them that way, but as we said before, right, this factor has a negative exponent. It goes to the other side of the fraction as positive. This factor has a negative exponent. It must go to the other side of the fraction as positive. So my final answer would be y20 and x10. Okay, now that both exponents are positive, this is my final answer. Okay. All right, very good. So let's do the one on the bottom here first. This may be easier for us to do. I have now an expression inside the parentheses with an exponent on the outside. So it's the last property, which is an exponentiation of an exponentiation, or an exponent of an exponent. So I have to do each individual term inside of the parentheses raised to this power of negative 3. So this is what I want you to do. You do it one at a time. So first 4 to the negative 3 times m to the 3rd to the negative 3 times n to the negative 4th to the negative 3. And now we do each one separately, even though they are together. So the first case, I have to convert this to a positive exponent, right? We cannot work the problem this way. So the 4 to the negative 3 is in the numerator, and it goes to the denominator as 4 to the third power. Now, these two is the last property. So m to the third raised to the negative 3 would be m to the negative 9th power. And n to the negative 4 raised to the negative 3 would be n to the 12th power, right? Negative 4 times negative 3, positive 12. So I'm almost done with this problem, with the exception that I have to evaluate what this is, and I have to turn this into a positive value. So the 4 to the third is 4 times 4 times 4, which is 64. The n square, n to the 12th power is already positive, so it stays in the numerator, but the m to the minus 9 must go to the other side of the fraction because the exponent must be left positive as the final answer. So the final answer is n to the 12th, 64 over 64 m to the 9. Okay? All right, very good. Let's do 825. And same thing applies. So 825 is similar to 826, with the exception now I have numerator and denominator. So I'm going to handle the numerator first. So 4 to the 4th, right? This exponent gets applied here and here, times 8 to the 6th raised to the negative 4th, negative 8 to the 4th, times b to the 3rd to the 4th, negative 4, right? Actually, this is to the 4th. I didn't see it before, so let's just erase this a little bit. So the exponent here is 4, so 4 to the 4th, 8 to the negative 6 to the 4th, denominator negative 8 to the 4th, b to the 3rd to the 4th. Now, notice that because both of these exponents are positive, I can combine the 4 and the negative 8 first, and I can simplify this first. All right, so positive divided by negative is a negative, 4 divided by 8 is 1/2. So this is going to be 1/2 to the 4th. Okay. Now, negative 1/2 to the 4th would be negative 1 to the 4th divided by 2 to the 4th. Well, negative 1 to the 4th is negative 1 times negative 1 times negative 1 times negative 1, which is just 1. And 2 to the 4th is 2 times 2 times 2 times 2, 4 times, which is 16. Okay. So I took care of these two numbers already. So I'm going to write them here, 1 and 16. And all I have to do now is the a to the negative 24, right? Last property, negative 6 times 4. And then the b to the 12, 3 times 4. Now, I'm almost done with the exception of this a to the minus negative to the 24th cannot stay as negative, as we've discussed before. So what do we do? That is in the numerator. It has to go back to the other side of the fraction. So my numerator is only 1 now. I have 16. A to the positive 24, b to the positive 12. And this is my final answer. Okay, so we had both properties here, including negative exponents, in one problem. So this is what usually will happen on your final exam or a regular exam, where you may have a problem where you have to apply multiple properties. And the last problem for this section is 828. This is probably a little bit more involved, but is absolutely no different than the one before, where we have to know multiple properties and simplify using those properties of integral exponents. So I'm going to take care of this exponent first, numerator and denominator. So I have 5 to the negative 3 times W, and I'm going to multiply as we go so that it doesn't get too cluttered. So I already know that I have to multiply the negative 4 times the negative 3. So this will be W to the 12, positive. And then V to the negative 6 times negative 3, which is 18. The denominator, I have 15 to the negative 3 times X to the 3 times negative 3, which is negative 9. All right, so the number part is similar to before, where I can, both exponents are the same, which means I can simplify the fraction separately. So I'm gonna do this thing here on the side. So I have 5 over 15 to the negative 3. So 5 over 15 is obviously 1 over 5 to the negative 3. And this is 1 to the negative 3 and 5 to the negative 3. Both exponents have to be converted to positive. So this goes up and this goes down. So I will have 5 to the third as my numerator, and I will have 1 to the third as my denominator. Now, obviously, 1 to the third is just 1, and 5 to the third is 5 times 5 times 5, which is 125. So I have the numerical part. Both of these stay in the numerator because they are already positive. And this factor has a negative exponent. It must go to the other side of the fraction, which is the numerator. And when it does, it becomes a positive exponent. So here's my answer, 125, W12, V18, X9. Now, let me just say one thing that I didn't mention before, but I'm sure you are aware of this. The order of these factors does not matter. Normally, we write the numerical answer first, and then you could write, if you want, X9, V18, W12, if you want. So this is correct. This is also correct. The order of these factors does not matter. We just normally write the numerical answer first, the number first, and then the variables after. Okay, so this is the section dealing with integral exponents. We've covered these 5 properties: the product rule, quotient rule, and the zero power rule, the negative exponent rule, and the exponent of an exponent rule as the last property dealing with these problems. And all of the examples that you see on the homework or exam or the final will be similar to these.